Hey team, today in this video we will look at part or component 1 of the practice SAC for Unit 1 Maths Methods on functions, relations, polynomials, and we'll jump straight in. I've got the component 1, part of component 1 there, and then the remainder of the questions down there for it. As you're aware, the assessment is about helping designing parts of a water slide or water park. So let's here we go. Let's jump straight in. So we know we have some function h of x that is in polynomial form cubic. We have 4 parameters in it, a, b, c, and d, that we will eventually have to find. We know the x-axis is measured in meters, and we know the vertical h-axis is in meters as well. We importantly have 4 data points, and we have 4 parameters. So this already, before we even get looking at the questions, I'm thinking I had 4 parameters, I have 4 data points. At some stage I'm probably going to be using simultaneous equations to try and find what those parameters are. And if we go look at the question, it is determine the values of a, b, c, and d, and hence write the equation for h of x. So we have h of x in polynomial form is ax cubed plus bx squared plus cx plus d. We can write in function notation that we know h of 0 is 7.5, which is a very important bit because that gives us one of the parameters straight away, but I'll come back to that. H of 2 is equal to 8.4. H of 4 is equal to 3.7, and H of 6 is equal to 7.8. Now, this first data point, which is here, that's our y-axis, and it's h of 0. So if we substitute 0 into these first 3 terms, they all disappear. That means straight away we get d must be equal to 7.5. Before we do any substitutions, we know as we're putting x equals 0 in, first term becomes 0, second term becomes 0, third term becomes 0. That must mean d must be 7.5 for that first data point to hold true, or the first coordinate. From here, we could substitute in x equals 2 and let it equal to 8.4. Let x equal 4, substitute in 3.7. Let x equals 6, substitute in and let it equal to 7.8, and get 3 equations, and then try and solve them simultaneously. Now, these are all decimals, so that would be a pain doing it by hand, and the SAC's are CAS active, so let's use the CAS where possible. The first thing we want to do is we want to define the function. So math 3 is define, and we're going to use f today for it instead. We're going to call it f of x, and it is equal to, and we go down to a, b, c, d, a, and we want to, even though it's ax cubed, I could type ax to the 3, and sometimes that might work, and it'll recognize that it's a times x to the power of 3. But you need to be careful because some computer algebra systems will think that that ax, 2 letters written next to each other, is just a single variable name. Especially in coding and systems, most variables actually use long worded names rather than the single letter to represent them to help with reading. So sometimes the CAS calculator will do that. So to be sure that doesn't happen, let's just actually put the times symbol in between, multiply symbol in between, so that we know that that is actually a parameter being times by the variable x. And that will occur for all 3 of these, times by x, and then at the end we're going to do 7.5 since we already know that's what is d. So we've defined our function as f of x, and if I go back and just write f of x and hit enter, now I have that. That's what it's defined, and it's already converted the 7.5 into fraction form because I'm in standard mode of the calculator. So from here we can use these 3 bits of data to solve simultaneous equation. This CAS is able to do that, and it is in Math 1, and it is this button sort of in the center just above the tan button. and I'll keep pressing it so you can see. And as you notice then, as I pressed it, or when I first pressed it, it only gives me 2 lines. That means it's going to solve a double simultaneous equation. If I press it again while I'm selected inside it, it'll add more lines, and I can keep adding as many lines as I need. But in our case, we have 3 equations that we're going to solve. Ooh, that's not what I wanted to do. Why is the backspace not working? Delete that. Okay, 1, 2. There we go. Okay, and we can, because we're already defined our function, we can put it in as function notation, and it'll automatically do all the substitutions for us. So f of 2 is equal to 8.4. F of 4 is 3.7. And f of, come on, f of 6, why is it getting a bit stuck there? Okay, f of 6 is equal to 7.8. Okay, so that's the 3 equations we want to solve simultaneously. This bottom box here is to tell them what variables we want to solve for. What do we want to know at the end, or the parameters. In our case, we want to know what A, B, and C are. So once we've got that set up, our 3 equations with 3 parameters we want to solve for, hit enter, and bang, we got them. So we get h of x is equal to 3 on 10x cubed plus, no, that's a minus 5 on 2x squared plus 17 on 4x plus 7.5. There we go. The only thing I should note here, and I haven't quite explicitly said in the question, it's open to interpretation. I wouldn't have taken marks from if you hadn't, but it's only asking for the equation, which you have given. If it asks for the function, we would need to note explicitly, it says in the question above, it says, the graph shows the section modeled by the cubic. So the cubic only models that section. The slide clearly has some bits before that and has some bits after, but the graph shows the only bit that's modeled by the cubic. So if I ask you to state the function, well, technically the function is only shown between those 2 points. So we would have to restrict our domain to say that x is greater than or equal to 0 or less than or equal to 6. You would want to add that in if it asks for the function, but at the moment you're only asked for the equation, so that is suitable. From here, we want to find the minimum, the maximum minimum height of the ride in this section. Give your answers correct to 2 decimal places. We can do this 2 ways. We can do it graphically on the CAS, or we can do it using commands or algebraically on the CAS, or using the CAS system. The thing we need to note is even though this CAS has figured out what A, B, and C are, they haven't stored them. They haven't gone back and adjusted this f of x. So if I tried to use this f of x command, it's still going to actually look like that. And I can prove that to you by going f of, x, and hit enter. It's still got the A, B, and C into it. So we need to actually redefine f of x with the correct coefficients. So let me use my mouse, be a bit quicker. We have 3 on 10 x to the 3 minus 5 on 2 x to the 2 plus 17 on 4x, and we also know it is plus 7.5 at the end. So now I've redefined it. If I just hit enter, it's actually now in correct form. So we can use that either in the graphing or in commands up here in action and interactive. So let's do the graphing method first. So y equals, and I'll delete that out of it, and graph. And since I already had f of x defined, I can just type f of x instead of the whole equation, and we can see. But as you can see, this continues on, and that's the hint you may have got looking, is we can put a domain in. And the domain is in Math 3, and it's this vertical line, middle far right above the square brackets, that vertical line. That means given. So given some conditions, and we now get to put the conditions in, and x is between or equal to 6. And if I put those in and now regraph, it has restricted the domain to the appropriate. And does it look like my actual picture that I was given in the problem? Yes, it does. It looks a little bit more stretched down the vertical component just because of the way the axes, if you look in the actual picture you're given, how far across horizontally 2 is versus how high up 2 is on the axes. They're different scales. But we're now dealing with the right thing. So from here, we can find where the minimum max is using analysis. And we can go into analysis, G-solve, and we want the min or the max, or f-min, f-max. So if we go the min, it finds that the minimum is there. So the min is at 4.508, and I'm not rounding yet, 3.3374. And our max, let's get those, analysis, G-solve, max, there we go, is 1.0475, 9.5535. Okay, now that I've got those coordinates, let's go back to the actual problem. Find the maximum minimum height of the ride, give your answer correct to 2 decimal places. Okay, so let's actually answer the question. So the min height is equal to, y-axis is going to be 3.34 meters, and our max height is going to be equal to 9.55 meters. There we go. So that's part A and part B done. Let's keep going here. So from here, 2 concrete pillars are supporting this section of the slide. The pillars meet at the point 284. Okay, so we have some pillars meeting at this point 8.4 and meet at the ground at 10 and 30. Okay, so one goes to there. So let's draw that pillar in, and one goes to 30 as well. And that goes to there. So 1, 0, 3, 0. Find the equation of the 2 pillars, equations, that should be plural, and give in the form of a piecewise equation. Okay, interesting. So I need to find the equation. So let's look at the first one. It is a line going from 1, 0 up to 2, 8.4. Okay. So how about we change colours here so we don't get confused. That was that bit, that was that bit. Okay. So first off, we want our gradient. So m is rise over run. So we can see our rise is 8.4 and over a run of 1. So we have a gradient of 8.4. Nice and easy. From here, so we know now that, let's call it y1 for the first pillar. Or let's actually call it p1. P1 is equal to, m is 8.4, x plus c. And from here, we want to substitute in one of these 2 coordinates. We can either substitute in this, or we can substitute in that to figure out what our c value is. Let's use the 1, 0, because that's going to make our life a whole lot easier. So let's communicate what we're doing. We're going to actually, let's move some stuff. Yeah. Let's bring that over there. Bring that over here. Okay, so we're going to substitute in 1, 0 to find our c value. So we get 0 is equal to 8.4 times by 1 plus c. So we get 0 is equal to 8.4 plus C. So we get C is equal to negative 8.4. That's our first. Therefore, our first pillar, P of 1 of X is equal to, what do we say? 8.4X minus 8.4 is our first equation. Happy days. The one thing we should probably have done somewhere in here is before I wrote this bit is actually defined what P of 1 is. Whenever we're dealing with problems where we're just making up our equations, our own values, we should say what it is. So let P1 of X be equation of first pillar. Want to communicate. If we're making up letters, unlike up in part A, part B, where we were told h of x, this one we've decided to use P of 1. We want to communicate that. So therefore, now to do the next bit is let P of 2 equal equation of second pillar. Okay, so let's do a little sketch of that second pillar. We're actually coming down from 2, 8.4, and we are going to 0, 3. Our gradient is rise over run, and our rise, since we're going down, is negative 8.4 over a run of 1, gives us negative 8.4. So from that, we have P of 2, P2 of X. Let's be a little bit consistent here in notation. P2 of X is equal to negative 8.4X plus C. Let's substitute in, let's go 0, 3. To try and figure out what C is. So we get 3 is equal to negative 8.4. Oh, it's 3, 0. What are we doing, Damien? My word. 3, 0. So we get 0 is equal to negative 8.4 by 3. Plus C, so C is equal to 8.4 times by 3, which is going to be 25.2, but let's 8.4, oh no, let's go main, 8.4 by 3, 126 on 5. Therefore, P2 of X is equal to negative 8.4x plus 126 on 5. Happy days. Now, we haven't quite finished the problem though. It says find the equation of the two pillars and give in the form of a piecewise equation. So we want to write a combination equation that says P is equal to some combination of P1 and P2. And the way we do that is we can use this symbol here. Okay, so P of X is equal to, and we get to write P1 was 8.4X minus 8.4, but that was only valid for X between, in our case, 1 to 2. 1 to 2. So that's what we say. Use this equation, 8.4x minus 8.4 between 1 and 2. Otherwise, you need to use negative 8.4x plus 126 on 5 between 2. And I'll talk about domains in a second, between 2 and 3. Now, there is an issue with this piecewise function as I've written it, and that would be which equation do you use when x equals 2? In this case, I have got it written that x equals 2 is included there and x equals 2 is included there, which is an issue. It's not properly defined. In this case, the points are matching, they overlap each other, so you could just pick one or the other. If they weren't overlapping each other, you just have to look at the equation or look at the graph and see which one had like a filled circle to mean it's including that point, and the other line, if they weren't touching, would have then an open circle to mean that one's not included. But in this case, they both are, but they overlap, so I'm just going to pick it this way. But either one would have been fine. So there's our piecewise equation. Calculate the angle made by these pillars with the ground. Give your answer to the nearest degree. Well, this pulls into remembering that the gradient is equal to tan theta, where that will be theta, the angle that it makes. And that's what we're actually wanting to find, is the angle with the ground to our nearest degree. Okay. So in our first one, we have P1, we have m equals 8.4, let that equal to tan theta. So theta will be equal to the inverse tan of 8.4, which will be equal to, and one thing with the calculator is be careful that you are in degrees mode. Keyboard, where's our trig? We want inverse tan of 8.4 gives me, oh, and let's go decimal mode as well. There we go, 83.21 degrees. Now, does that make sense? Well, yeah, a gradient of 8.4, it is very straight up and down line like so, which matches what's happening here. Okay, even with the scale skewed axes, it's a very steep line. So that's the gradient that it makes with the ground, and how many decimal places gives your answer to the nearest degree. Okay, so theta 1 is roughly equal to 83 degrees, and for our second pillar, P2, m is equal to negative 8.4, so tan theta is equal to negative 8.4. Theta is equal to inverse tan of negative 8.4. So inverse tan negative 8.4, negative 83 degrees, which makes sense. So negative 83.21. It's the same angle. Now, we want to state what angle it makes with the ground. So there, yeah, that matches. So sometimes just using m equals tan theta, you have to be careful which angle it's giving you versus what angle you're being asked to find. In this case, we're just the angle with the ground, so we could think of this the internal angle there. So theta 2 is roughly equal to, again, 83 degrees. Do we need to state whether it's negative or positive? No, not really, because it's just an angle with the ground. How far, as we lift that pillar up from the ground, what angle is it going to be at? Well, it's 83 degrees. Rightio. Calculate the length of the two pillars. Give your answer correct at 2 decimal places. Okay, so length of any line segment is equal to the square root of x2 take away x1 all squared plus y2 take away y1 all squared. It's just Pythagoras' theorem of between two coordinate points. So let's use a line that goes from 1, 0 up to 2, 8.4. So square root x2 is 2 take away 1 all squared plus 8.4 take away 0 all squared gives us the square root of 1 plus 8.4 squared. Okay, square root of 1 plus 8.4 squared gives me 8.45931, so it's roughly equal to 8.46 meters. Okay, and since the pillars are identical, they're just one's going up, one's going down, we could say length of each pillar is 8.46 meters. Happy days. Lastly, draw a sketch of the ride and the pillars. I'm not going to do everything, but the key things here is that you include any key information that you have been given or that you have figured out that has to do with the appearance of the graph. So what I want to see, if I come back and draw on this, okay, is effectively what is there already. Okay, you want nice ruled axes. We want to put in accurately those 4 data points because we know the graph has to go through those 4 data points and we're given the shape already. So you can't butcher the shape. You must recreate what's there. And then also, we want nice ruled lines for the pillars and just labeling in these 2 coordinates. And that's what we would want. Yes, but the big thing is looking for not butchering this shape. You don't want some funky graph. No good. Okay, but that's it. That's for component 1. I will release some more videos for components 2, 3, and 4 shortly.